Greeting everyone. Our group number is 53. Our project title is Real Time Indian Road Sign Detection. I am Kaavya Verma from EC6.
My name is Sourav. I am from branch ECE.
My name is Abhinav Bajaj and my branch is EC.
My name is Pulkit Gulati. I am from ECE.
My name is Gulfam Khan and my branch is ECE.
In this project, let me introduce you first. So everybody around us have seen that the presence of road signs. These are very important in our day-to-day life. Without them, there would have been number of thousands of accidents. And so we have proposed a model for prevention of accidents on roads. So the primary goal of the suggested system is to automatically recognize traffic signs while driving and adjust speed or perform in accordance with them. So to propose this model, we have used a technology called YOLO, which is you look only once, and implemented on Raspberry Pi. In earlier times, people used fast RNN and faster RCNN. We have used YOLO because according to a report, it is nearly 6 to 7 times faster than these two proposed schemes, that is fast RNN and CNN. So not only in rural areas, but in urban, not only in urban areas, but also in rural areas, we have to take precautionary measures about the road sign detection. So this scheme is valid all over India. And now we will come to the need. According to the report, in 2020, there were nearly 4 lakh accidents. So someone has to come forward to down the records of these accidents. So we have proposed a model for this. And also, this primary goal of this project is to offer an effective method for detecting and identifying traffic signs in India. And the traffic sign help drivers drive more attentively and professionally. Traffic sign recognition systems are a crucial component of the intelligent transportation system.
Dataset and classes. As the project is based on Indian traffic road signs specifically, but over the internet, there was no specific dataset available for it. But by researching, we get to know about a dataset which is German road sign dataset, which is compared like most likely Indian traffic road signs. We did some additions in the traffic road signs in the dataset and classified them into different classes. The dataset was split into 3 subsets. We applied stratified sampling. This makes sure that the overall class distribution is preserved for each individual set, and all images of one traffic sign instance are assigned to the same set, as otherwise the dataset could not be considered independent. Split separates the data into 75-25. That is 75% of data is training set and 25% in testing set. Out of 75% testing set, we have 50% basic training test sets and 25% validation set. Now moving on to the flow chart, the very first step in the process is capturing the data, that is road signs, which we have done by video capturing done by the camera. The next step in the pre-process is the pre-process of the captured data, which involves getting only the important video frames that can be useful in detection of the sign. After that, the next step is detection by the YOLO V5 model. If the road sign is detected in a dataset, then the image classification and characterization are done and alert message is sent to the system. If the road sign is not similar to the road sign in our dataset, then the frame is discarded.
So in this part, I want to discuss about the methodology we used in this project. There were several machine learning models available over the internet, like fast RCNN and the faster RCNN. But the problem with these models is that in the process they used, they were the two-step verification, which was resultant in the slow identification of the object in the real time. So we moved with the YOLO. YOLO stands for the you look only once. So YOLO is faster method of the detection, which provides a result with a single glance. YOLO algorithm based on the 3 steps, that is the residual blocks, bounding box regression, and the IOU. YOLO algo divides the image into the grids and perform object detection. Later, it defines the bounding box around the object. The bounding box are later matched with the annotated bounding box around the object, and the IOU factor is calculated. Then the intersection over union assures that the expected bounding box of the objects are equivalent to the actual boxes, and later the classification is being done. And here is the video demonstration of the project. Since we can see that the 30 km/h speed is being identified, here is the stop sign is being identified. All the images have been taken from the internet, direct from the Google. And here is the no entry sign. At last, I want to conclude that the basic idea is to recognize and classification of the traffic sign in the real time. YOLO model have delivered what it promises: the fast speed, optimal accuracy on the lightweight model as the Raspberry Pi we used. So there, as we tested the model, it given a very parity accuracy of nearly 97%. And in the future, we can hope in the transition of the architecture to more mature frameworks such as the Cafe or the Torch to support a quicker development cycle, that the speed of the detection could be improved. Thank you.